Let's take a look at some examples of using the superposition theorem. Let's start off with two voltage sources. Use the superposition theorem to find the current through resistor R2 in the figure. So step 1 says we replace the voltage source 2 with a short and find the current through R2 due to the voltage source 1. To find I2, use the current divider formula looking for Vs voltage source 1. So the total resistance for source 1 is equal to R1 plus R2 by 2, okay, because they're both the same value. So we've got 100 ohms plus 50 ohms gives us 150 ohms. So now we say the current total from source 1 is equal to V source 1 over R total source 1. So that's 10 volts divided by 150, which gives us 66.7 milliamps. The current then through R2 due to voltage source 1 is current source 2, source 1, is equal to R3 divided by R2 plus R3 times the total current for source 1. 100 ohms divided by 200 ohms times 66.7 milliamps gives us 33.3 milliamps of current. Note that the current is downward through R2. So there's the representation of the circuit that we just talked about. Okay, so we replaced the source with the short, and we calculated for R2. So now step 2 says find the current through R2 now with voltage source 2 and replacing voltage source 1 with a short. So our total then of source 2 is equal to R3 plus R1 by 2. Again, they've made this real convenient because all three of those resistors are the same. So now this is shorted out. That puts R1 and R2 in parallel. So again, 100 plus 50 ohms gives us 150. I total then is V source 2 divided by R total, 5 volts, divided by 150 ohms gives us again 33.3 milliamps. The current through R2 due to voltage source 2 is then R1 divided by the sum of R1 plus R2 times the total current from source 2, which gives us 100 ohms divided by 200 ohms times 33.3 milliamps, or 16.7 milliamps. Again, we note that the current is downward, and we'll see that right here. So there's that current downward. There was the source that was replaced with a short. The last step then is both component currents are downward through R2, so we have the same algebraic sign, therefore we add the values. So 33.3 plus 16.7 milliamps gives us a total of 50 milliamps. So that is your superposition theorem with two voltage sources. Now, what if we replace one source with a current source where we have one voltage source and one current source? So find the current again, R2, through the circuit. So we've got a current source on the right, we've got a voltage source on the left. So we're going to find the current through R2 first by opening the current source. We're going to find the current through R2 due to voltage source 1 by replacing the current source with an open. And when we do that, again, that kills any current in this part or this branch. So all we're left with is any current due to voltage source 1 or the 10 volt source. Notice that all the current through V source is through R2. Looking from V source, then our total is R1 plus R2, or 320 ohms. The current through R2 then due to the voltage source is current 2, V source is equal to V source by R total, which equals 10 volts by 320 ohms, or 31.2 milliamps. Again, notice that the current is downward. So now we put the current source back in and we short the voltage source. So in doing so, then we use the current divider formula to determine the current through R2 as by IS. That's our source. So current 2, current source, is equal to R1 divided by R1 plus R2 times the current source. 320 ohms by 220 ohms by 320 ohms times 100 milliamps gives us 68.8 milliamps of current I2. Note that the current is again downward. So since the current is downward again in both cases, we can add them together. So I2 V source, I2 I source gives us 31.2 milliamps plus 68.8 milliamps, or 100 milliamps of current through I2. Now we look at superposition using two current sources. So with two current sources set up this way, we've got 100 ohms on the left, we've got 56 here on the right, and two current sources with opposing current directions. So they want us to find the current through this resistor on the far left side. Find the current through the 100 ohm resistor due to the current source 1 by replacing the current source 2 with an open. As you can see, the entire 10 milliamps from the current source 1 is downward through the 100 ohm resistor. So we've opened this up. Again, all of this disappears because there's no current, and our current flow given by the direction of the arrow is downward through the 100 ohm resistor. So we find the current through the 100 ohm resistor now due to source 2 by replacing the source 1 with an open. Notice that all of the 3 milliamps from the source 2 is upward through the 100 ohm resistor. So again, because we have opposing currents. Now to get the total current through the 100 ohm resistor, subtract the smaller current from the larger because they are in opposite directions. The resulting total current is in the direction of the larger current source, I source 1. So 10 milliamps minus 3 milliamps gives us 7 milliamps, resulting in a downward current through the resistor because that was the prevailing source. Superposition then with two voltage sources. Okay, this one looks a little different. They want us to find the total current R3 in the diagram. So we've got R3 hanging off on the side here to the far right. So find the current through R2 due to the source V source 1, which is the 20 volt on top, by replacing V source 2 with a short. So we're going to short V source 2 here, which is going to put R2 and R3 in parallel with each other. So looking from V source 1, the total resistance due to source 1 is R1 plus the product over the sum, R2, R3 divided by R2 plus R3, which gives us, when we plug in our values, 1 k ohm times 2.2 k ohms divided by 3.2 k ohms, a 1.69 k ohm total resistance. Now the total current due to source 1 is equal to V source 1 by our total source 1. 20 volts divided by the 1.69 k ohms we just calculated gives us a total current of 11.8 milliamps of current. Now we apply the current divider rule to get the current through R3 due to source VS1. So here's our current divider rule. Current 3 source 1 is equal to R2 divided by the sum of R2 and R3 times the current total from the source 1. 1 k ohm divided by 3.2 k ohms times 11.8 milliamps gives us 3.69 milliamps. Again, notice the direction of the current. It is downward through I3. Okay, now we're going to find current 3 due to the source V2 replacing the source V1 with a short. Okay, so we're only going to put V2 in. We've got V1 shorted out. So looking from voltage source 2, we have a total resistance of R2 plus the parallel R1, or the sum, product over the sum of R1 plus R3, R1 plus R3. And that gives us 1 k ohm, and the product 1 k ohm times 2.2 k ohms divided by 3.2 k ohms, which gives us now 1.69 k ohms of total resistance with just source 2. Now we can find the total current of source 2 as V source 2 divided by R total source 2. That's a 15 volt source divided by 1.69 k ohms, or 8.88 milliamps. Now we apply the current divider rule to find the current through R3 due to source 2. So I3 is equal to, I3 source 2 is equal to R1 divided by the sum of R1 and R3 times the total current due to source 2. 1 k ohm divided by 3.2 k ohms times 8.8 milliamps gives us 2.78 milliamps. Notice that this current is in the upward position, okay, because again our sources were opposing. So now we calculate the total current through R3. Since they were opposing, we have I3 source 1 minus I3 source 2, which is 3.69 milliamps, minus 2.78 milliamps, or 9/10 of a milliamp, or 910 microamps of current. This current is downward. So superposition is just a way of solving one part of the circuit by turning another part off and combining them in the end.